Dear student, I am Dr. Harel Thomas, Professor in Applied Geology, Dr. Harisingh Gour, Vishwavidyalaya, Sagar. Today, in this course, I will deliver my lecture on texture of sedimentary rocks. Today, I will proceed under the following heads: introduction, classification, type of sedimentary structures and summary. Hope it will be useful for you. Try to be regular in course. Sediment is a solid material that has settled down from the state of suspension in a liquid. Any of the layered rock resulting from the consolidation of sediment is called sedimentary rock. Sediments are transported by wind, glacier and also by the water in 4 different ways. For example, sliding, rolling, saltation and suspension. Structure signifies large scale features developed in the rock masses during their formation. The structure of sediments also best studies in outcrop rather than in hand specimen or thin section. The small scale geometrical aspect of the constituent grains are commonly distinguished as texture. Sedimentary structures are formed during or after deposition and also during diagenesis. Structure in sedimentary rocks are visible because of local variation in texture and composition. It is expressed by rock unit of generally tabular or lenticular forms that have some lithology and structure and are thus set off from other strata with which they are interleaved. The most nearly universal primary structure of sedimentary rock is bedding or stratification. The table on your screen, the thickness in centimeter, especially for the bedding planes or stratiform structures. Beds differ from the layers above and below by virtue of some discontinuity in rock types. Internal structure or texture, the lower boundary of the bed is called soil. Different parts of the beds separated by minor but distinct discontinuities in texture or composition are called layers. Classification of sedimentary structure. Classification of sedimentary structure can be classified into 2 types. First, morphological classification based on the form or geometry and place of occurrences of sedimentary structure. Second, genetic classification based on the process involved in the formation of sedimentary structure such as biogenic, hydrodynamic, etc. In classification, it is more meaningful to use a system involving both genetic morphologic grouping. Sedimentary structures are classified as mechanical, chemical and biogenic structures. Inorganic structures are shown on table of your screen. Organic structure, biogenic structures, petrified stromatolites, trials, fossils. Type of sedimentary structures based on bedding geometry, lamination. It may be formed due to transitory phases or minor fluctuation in velocity of the depositing current. It is characterized by the grained sediments, notably siltstone and shell. Beds less than 1 centimeter are called as lamellae. Wave bedding, it is characterized by interbedded rippled sand and mud layers completely out of phase with each other. Second, bedding internal structure. Cross bedding, it is an internal feature and is a product of migration of a mega ripple or sand wave. Cross bedding means bedding with a high initial dip. There are two types of cross bedding: tabular cross bedding and trough cross bedding. Second, ripple bedding. It is applied to micro cross lamination produced by ripple migration. There are undulation of the sediment surface produced as wind or water move across. Sand ripple bedding may be: first, asymmetrical ripples, current ripple marks; second, symmetrical ripples, wave ripple marks; third, graded bedding. Graded beds are sedimentary units marked by a gradation in grain size from coarse to fine, upward from base to the top of the unit. Graded beds are deposited from wave current, and many range in thickness from a centimeter or less to 1 or more meter. Graded material may be silt, sand, or in rare cases gravel. Usually most graded beds are sandstone and range from few centimeter to meter in thickness. Fourth, growth bedding. This term is applied for the stratification produced by in situ activities of organism or by chemical precipitation on surfaces of accumulation. Third, bedding planes marking. When beds separate rapidly along bedding plane, the surfaces produced commonly display various marking and structures. Markings found on the lower side of the beds are known as sole marks. In score marks, they are mainly due to current action. They are produced by cutting or shearing action of a water current flowing over the bottom. Second, tool marks. It differ from sore marks as being produced by the object carried with the bed rather than flow itself. The tool may be wood fragments, shells, pebbles, etc. Fourth, bedding planes marks on surface, pit and prints, rain, hills and spray impression, or a small circular to ellipsoidal pits formed in wet mud by the agent. These marks indicate environment or onshore environment of the depression. Mud cracks. It is an irregular fracture in a crudely polygonal pattern formed by the sinking edge of clay, silt or mud in the course of drying under the influence of atmospheric surface condition. Fifth, deformed bedding structure. Cumulates bedding. A single thin sandstone or siltstone layer, siliceous or calcareous silt get folded and the internal lamination may get contorted. Deformation appears as highly contorted, folded, tufted layers. Load cast. These are structures produced by the sinking of heavier into lighter sediments. They are somewhat irregular, bulbous or mammalia feature on the base of a sandstone beds that overlies shell. Ball and pillow structure. Some sandstone like some subaqueous lava flow display a pillow structure. The sand appear as numerous closely packed ball or pillow like form and termed as pseudo nodules. They are not a primary depositional feature but are instead a product of deformational feature which took place before the deposition of the overlying strata. First, stalolites. Stalolitic seam is a surface marked by a interlocking or mutual interpretation of two sides. The tooth-like projection or one side fit into socket-like dimension on the other. In cross section, the stalolitic structure resemble a surface. They are very abundant in carbonate rocks and may also occur in some sandstone and quartzite. They even occur in gypsum and probably in anhydrite and salt. Vokes are the pores related to the primary fabric, which is a result of solution activities in limestone. The actual pores may have had a complex history. A skeletal element, for example, may be removed by solution, leaving the molds, which may be enlarged by further solution and converted into a irregular vokes. Olecast. These structures are displayed by a rock having oolitic texture. Oolites are small spherical axillary bodies generally ranging from 0.25 millimeter to 2 millimeter in diameter. If the diameter is greater than 2 millimeter, the texture is called piezolites. Oolites appear to grow outwards from a center, which is formed by the solution activities in carbonate rock. Partial to complete solution of the voids leave a void that may later be filled by inward growth of crystalline matter such as silica in calcareous wood. These are called as olecast or axillary structure. Accretion as defined by Torts in term used based on growth manner. Accretion, growth from the center outward in a irregular manner. Nodules, local chemical precipitation and reaction. Nodules, local chemical precipitation and reaction creates structure commonly referred to as nodules. They occur in host sediments of virtually and compositionally. A nodules is generally spherical or irregular, rounded in shape. These are typically solid replacement bodies of chert or iron oxide formed during diagenesis of sedimentary rocks. Concretion, it consists of round or irregular masses of more resistant rock formed as a result of precipitating around a core material, usually of fossil or grain of different composition. Geodes. Geodes are essentially rock cavities with internal structural formation or concentric bending. The exterior of the most common geodes is generally limestone or related carbonate rock, while the interior contains quartz crystal and chalcedony deposits. Geodes are characteristic of certain limestone beds, but are rarely found in shell. The formation of a geodes is first origin of cavity and filling of it by diagenesis like recrystallization in the center area. Silicification of the exterior followed by the central portion and subsequent precipitation of crystalline filling. Septaria. Septaria are large 10 to 100 centimeter, distinctly oblate nodules characterized by series of radiating cracks that widen towards the center and the die out near the margin that is crossed by a series of cracks concentric with the margin. Cone in cone structure, this structure is typical certain black cell and is characterized by an abundance of right circular cone with cone axis perpendicular to the bedding. Biogenic structure, these structures are formed as a result of direct or indirect effect of organic activities. Petrification, it is the replacement of inorganic matter by organic matter. It is a cell to cell replacement where the original structure of the organic matter is preserved. Example, petrified wood, petrified cells, etc. Stromatolites, it is a laminated structure composed of particulate sand, silt, clay size sediments which have been formed by the trapping and binding of the detrital sedimentary particles by an algal mat. Trace fossils, these are the records of the life and events that took place in situ during or soon after the deposition of the sediments. They include footprints, crawling marks, track, trails and burrows. Application of sedimentary structure, they reflect upon the nature of the environment during sedimentation. Second, the style and orientation of ripple marks may also be used as an indication of which direction the water was flowing at the time of sedimentation. Third, biological structure are useful in places to determine stratigraphic order in a vertical overturned sequence. Trace fossils can be mapped and used to define major facies belt. Fifth, ripple bedding is useful in determining stratigraphic order in giving evidence of the direction of current flow and in indicating flow condition. The formation of sedimentary structure is due to the cooperative operation of process like weathering, erosion, transportation and deposition of the sediment as well as solution and precipitation and also the accumulation of organic remains. The sedimentary structure also large scale feature and the study of them help us to understand the environment of deposition, ancient life activities, stratigraphic order of beds, paleocurrent, flow direction, etc. Thank you very much.